Exercise 1034 is telling you to use ethylene. Now that's the common name for ethene. Ethene, interestingly, is a plant hormone. It's a gas that's used to make all fruit ripen. So any fruit that's ripening is releasing this ethene gas, and that would just look like this. Now that's the only place we can get carbons from, and doing that, they want us to create 3-hexanone. The suffix there is the suffix for a ketone, and so you'd have 1, 2, 3, 4, 5, 6 carbons, that's the hex, and on carbon number 3, you'll have the ketone right there. So that's 3-hexanone. 1, 2, 3, 4, 5, 6. Okay, so how can we make this happen? Well, the first thing you'd want to see is that we have to form new carbon-to-carbon bonds. And the only way we can form new carbon-to-carbon bonds is by using a triple bond. We can use alkylation. So the first thing we have to do is be able to turn this into a triple bond, to turn that into acetylene. And we can do that. We've seen how to do that several times in previous videos. First, you add the halogens, so you do halogenation. That adds 2 bromines across the double bond. Then, once you do that, you do 2 eliminations. So you use excess sodium amide, followed by a water wash. So you don't have any carbon nucleophiles left over, and that turns that into acetylene, or ethyne. So using those 2 steps, we can get ethyne. Okay, so let's set that aside. Now we can use ethyne because we can show how we can make it from ethene. Now, we want to add, this is just 2 carbons, but we can add carbons on both sides. So imagine if this were the 2 carbons in the middle, we could add 2 carbons on each side of it. All we would need, we'd have to just do alkylation, so we treat this first with sodium amide. That strong base will rip the hydrogen off the end here and turn this into a nucleophile, and then add the carbon chain that you want to add so that you can do an SN2 reaction. Here we would want 2 carbons, so I have 2 carbons, just with a leaving group on it, and that would add that there. And the truth is, I could do that again to get the others, to get the other one. So I could add sodium amide, followed by another 2 carbons with a leaving group on it, that other carbon chain that we want, and with an SN2 reaction, you would get that attaching there, as we've discussed in detail in a previous video. So we're almost there. We're certainly much closer. We have the carbon chain we want. The only problem is all of our carbons have to come from ethene. And here, we've used these carbon chains that have this bromine on it. So how can we turn ethene into the group that we want? Well, you'll notice you have an alkene. That means you would do an addition reaction. What are you adding? A bromine and an implied hydrogen. So this is just hydrobromination. So you can do hydrobromination to turn ethene into bromoethane. And then once you do that, you can use that bromoethane to create this 6-carbon chain, just using it twice. Now once we have this 6-carbon chain, how can we turn it into a ketone? Because that's what we have here, a carbon double bonded to oxygen with a carbon on each side. The way you can turn an alkyne into a ketone is by using acid-catalyzed hydration. And because the carbons, both of the carbons here are secondary, you could use any type you want. For example, you could use acid-catalyzed hydration. And you'll add the H and the OH, and then it would ketoenol tautomerize to give you the ketone. So, we saw down here how we could use ethene to create ethyne. And then we saw how we could also use ethene to create this haloalkane. Putting all of that together, we can use ethyne and the haloalkane, do alkylation to create the 6-carbon chain. Once you have the 6-carbon chain, you can add H and OH by using acid-catalyzed hydration, and that ketoenol tautomerizes to give you the ketone. So that is a quick overview of the process you'd go through with exercise 1034. It builds on everything we've talked about in the last two chapters, so it's a very cumulative type of problem, and it requires mastery in everything that we've gone over so far. So if this video was not comprehensible, I strongly encourage you to go back and master the separate videos where we talk about each of these things. Alkylation, there's a long video on that, and then also acid-catalyzed hydration. And from the previous chapter, and also we have a couple of videos in this chapter where we talk about how to turn an alkene into an alkyne. And in the previous chapter, we had hydrohalogenation. So all of those come together in this larger, more cumulative problem.